This past Monday, we jumped feet first into SD-WAN and its bucket of nuts and bolts. We talked about how mixing broadband, LTE 5G, as well as fiber can give PSAPs more bandwidth and resilience that they need. But the cables are just the concrete. What if the real magic isn't in the wires, but in the software brain that's doing all that routing around trouble, prioritizing the life safety data, and even running compliance tests autonomously when it thinks there might be trouble? Imagine a network that's able to anticipate congestion before you hear the first busy signal and then shunt a 911 call around a fiber cut without ever missing a beat. Is that the future? Hang around and find out next on this episode of TiPS, Today in Public Safety.
Welcome to TiPS, Today in Public Safety, your go-to podcast for today's breaking stories and public safety news. Here's your host, Fletch, with today's tips.
Welcome to TiPS, Today in Public Safety. This is Fletch. I'm an NETA certified ENP, and every Monday, Wednesday, and Friday, I bring you the latest in technology and public safety communications. SD-WAN, more than just a network. Now, back on Monday, we celebrated the physical side of the software-defined wide area network. Its ability to combine multiple transportation types and steer traffic dynamically and lower those operational costs by using commodity broadband as well as wireless links. We pointed out how SD-WAN simplifies the network management with policy templates and its detailed performance reporting capabilities. Now, the value for public safety is that it means fewer outages, much lower circuit costs, and better uptime overall when it matters the most. But today's focus is going to be what happens above the pipes, the operational layer, because that's something different that SD-WAN can deliver. You see, traditional WANs were built to move packets of data efficiently from point A to point B. They didn't really enforce or care about the application level SLA agreements. And those networks don't run by themselves. They require administrators managing a bunch of disparate products, all manually. And that adds cost, adds complexity, and that's where SD-WAN is able to turn this paradigm on its head. And it does that by decoupling the control plane from the hardware, exposing the control APIs and policy engines. Now, what does that mean in English? It means that your WAN becomes programmable. It'll do what you want, like a cloud platform or a software-defined data center. Now, that logical shift really matters because in public safety communications, they increasingly depend on dynamic real-time media sources, location updates, sensor feeds, and more data like text to 911 coming in from the field. You've got remote dispatch consoles, GIS overlays, and video from the general public. And that means that old hub and spoke model really can't handle those demands, or at least not do it without adding a bunch of latency and bottlenecks, two things that kill a network almost immediately. Now, this new data model has got to prioritize traffic based on the context as well as policy, not just a hop counter and default routes. Dissecting the problem. Yesterday's legacy wide area networks weren't built for the cloud-centric, high-availability environments of today. No, they optimized packet flow, but not the performance of the specific applications. Agencies often struggled with hardware from multiple vendors and manual configuration at each branch level, which just increased the operational overhead. And that conventional model routes all traffic back to a central data center, which made sense when the applications lived there. But with cloud adoption and cloud-native applications, pulling everything back to headquarters actually increases latency and reduces the overall performance. Now, in public safety communications, that rigidity becomes dangerous. Public safety networks need to support sessions from nomadic users, remote telecommunicators, and even mobile command posts. They've got to deliver tons of data like GIS, building plans, and sensor alerts directly to the right dispatch console at the right time. Those legacy static networks can't easily handle those diverse workflows. Meanwhile, remote work and hybrid work has become the norm, and public safety is taking advantage of that technology. That means in a disaster, your call takers may be logging in from remote kits from home, or at least a backup center that was set up on the fly. The pandemic forced us to develop network agility that is no longer just a luxury. It's an essential mechanism for continuity. And it's these realities that expose gaps in manual configuration and the lack of built-in security, as well as the difficulties with near instantaneous traffic rerouting that's required. The programmatic solution. This is where the programmatic SD-WAN comes into play. You see, modern networks will expose RESTful APIs that allow engineers to script site provisioning, push out policy updates, and monitor the network performance without actually having to log into individual devices. And even industry analysts note that SD-WAN's programming nature will give agencies the ability to dynamically route traffic along an optimal path and reroute around outages. Now that's important because instead of waiting for a human to notice that a link is getting congested, the network can shift to a healthier path by itself, often before anyone even notices. Now, even more transformative is the integration of artificial intelligence and machine learning to handle these problems. It's expected that by the end of 2026, standard SD-WAN solutions will increasingly use AI and ML to automatically predict outages, optimize traffic, monitor performance, and then automatically adjust policies accordingly. And it's these capabilities that move network management from reactive troubleshooting to proactive assurance. Brand new platforms like Connect's AI-driven service framework use that machine learning to automate services and IT operations, and that can accelerate cloud migrations. The Connect's Maestro portal orchestrates services, monitors network health, and then chains in security functions like secure web gateways and zero trust access autonomously. The Juniper Mist AI partnership adds a virtual network assistant in that can deliver automation and insights from client to cloud. And it's together that those innovations create an AI-enabled programmatic platform that's able to self-optimize during trouble. Now, the public safety use cases are far and wide, ranging from real-time call routing and location updates, allowing policies to prioritize 911 calls as well as GIS data, and allowing AI to detect packet loss and shift sessions to a healthier link before any quality deteriorates. And with dynamic situational awareness, API scripts can push incident data, updated maps, and sensor feeds to both dispatch consoles and field units as needed. So when a building sensor triggers a CO2 alarm, the network can prioritize that data and get it to the right responder quickly. For mobile command posts and pop-up PSAPs, those deployable field units can bond fiber, 5G LTE, as well as satellite links. Then AI can choose the best combination for each application that balances both cost, latency, as well as reliability, while enforcing the required encryption and zero trust policies to keep the network safe. And that expands out to remote telecommunicator support, where telecommunicators can work from home in a disaster, or a backup center by connecting via secure SD-WAN tunnels that prioritize call signaling, and that maintains voice quality while providing CAT access. Then you've got automated compliance testing that's able to schedule test calls. APIs can generate test events, validating address records, and even producing an audit report on demand. For the enterprise and corporate environment, that supports Kerry's Law, Raybaum's Act, and Next-Gen 911 readiness without requiring interaction by manual labor at the PSAP. And this new topology allows network segmentation for shared services. So PSAPs that share infrastructure with other county services are able to create virtual segments with separate policies, separate bandwidth guarantees, and security rules. And you've got new IoT and sensor integrations that emerging public safety solutions can use that include gunshot detection, fire alarm panels, elevator alarms, and panic buttons. These programmatic SD-WAN architectures are able to recognize the data flows and prioritize them appropriately on the network. And modern SD-WAN solutions often integrate with secure access service edge frameworks, basically delivering a unified approach to both connectivity and security. And that's what allows microsegmentation as well as deny default policies that agencies can apply for zero trust principles across the network. And now network vendors are even offering AI-driven microservices that are able to provide visibility into application performance from every single device, and enabling a very fine-grained service assurance for mission-critical applications. That's all pretty cool. How do I get on board? So if you manage a public safety network, the path to programmatic SD-WAN can be straightforward, but it does require some planning. One way to get started is by taking inventory. Look at your API readiness. Do your network controllers offer open APIs that allow automation? Can you use templates to push configuration changes as well as test them safely? Then you've got AI and analytics. Does your vendor even offer AI ML capabilities that'll let you proactively resolve issues? And be sure to ask how they train their models and what data feeds that they're going to require. Examine your security and zero trust policies. Are you able to enforce microsegmentation, deny by default, as well as multi-factor authentication for those remote users? And find out how the SD-WAN is going to integrate with your existing firewalls, the identity providers, as well as the various logging platforms. Then you've got programmatic workflows. Are you able to integrate automatic test calls, GIS updates, sensor data and video feeds, as well as other workflows? Are there APIs for location management and NG911 interfaces? Then you have cloud and multi-cloud alignment. Do you use multiple cloud providers or just one? And determine if your SD-WAN can even steer traffic onto the correct cloud without having to hairpin the network through a data center where you'll increase latency and affect your user experience. Now, once you have all those answers, you'll be able to pilot technology, but you're going to need a lab environment or a backup site to be able to build and test all those programmatic policies. You'll want to be able to script the provisioning of a new PSAP extension or mobile command unit, as well as run test calls, verifying that location and notifications all work as expected. You'll be able to compare performance information both with and without AI-driven optimization and involve your network IT, GIS, and operations teams to make sure that you're aligning with goals and outcomes. Get ready to evaluate your vendors, be able to request demos, proofs of concept, and get all that written documentation that demonstrates how their solution supports things like Kerry's Law, Ray-Bombs Act, NG911, and NINA I3 interfaces. The reality check. Now, as exciting as programmatic SD-WAN sounds, remember not all promises deliver, especially in IT. AI is only as good as the data that it receives, and poor telemetry or misconfigured sensors can definitely trigger false positives, and that can cause unnecessary failovers. Also remember that open APIs can also introduce security risks, so get ready to manage that with strict role-based access and auditing. Plus, you'll need to plan for interoperability with those legacy systems that may still be required and have to support gateways or integration layers. Finally, don't forget about your staff training, because that is critical. Engineers are going to need to learn new automation tools, scripting languages, and zero trust framework policies that need to be carefully designed to avoid inadvertently starving non-emergency traffic that's still important on the network, like administrative emails or training videos. And be extremely cognizant of vendor lock-in. That can be a concern, where certain capabilities only work under a single brand. Ensure your platforms are supporting open standards and multi-vendor integration, because that's the real world. Finally, be sure to examine your budgets and procurement cycles, because they can slow adoption. And while subscription-based SD-WAN can lower your operational costs, sometimes the initial investments and staffing can still be significant. Whatever you do, be sure to plan ahead, but don't let the inertia prevent you from modernizing. because the cost of inaction could be far greater. The bottom line. Here's the thing, the physical diversity that SD-WAN offers, allowing you to mix fiber, broadband, 5G, and satellite, is still crucial. But it's the brain of the network and its programmable control plane where the future lies. AI-driven programmatic SD-WAN gives agencies the ability to respond faster, scale smarter, and focus on the mission rather than the plumbing. It's able to transform the network from a cost center to a strategic asset that supports NG911, rich data communications, and resilient operations. So the takeaway is, don't just upgrade your circuits, upgrade your network's intelligence. Because in public safety, it's not just about the bandwidth, it's about making every byte count when every second counts that rides on it. That wraps up this episode of TiPS Today in Public Safety. I hope you learned something new about programming the WAN and not just provisioning it, and how it can help keep people safe at the end of the day. Remember to like and subscribe, and as always, thanks for what you do every single day. It's your dedication and innovation that keep our community secure, and I, for one, am honored to be able to support you with the insights that bridge technology and public safety. Take care, we'll catch you next time.
You've been listening to TiPS Today in Public Safety, your go-to podcast for today's breaking stories and public safety news. Hosted by Fletch and available every Monday, Wednesday, and Friday. Catch past episodes on 911tips.com. Be sure to like and subscribe, and remember to join us each week for the latest on NG911. I am Spider Harrison, the official 911 voiceover dude. Catch me on Sirius XM on various channels, including 90s on 9, the 10 spot, and on the Weekend Countdown on Hits 1. Or don't regret it for the rest of your life. Either way, I'm good.